In this video, we will learn about piecewise functions. You can think of piecewise functions as a combination of various functions pieced together. Here's an example of a piecewise function. What is the value of the function when x equals -1? It's 2. What is the value of the function when x equals 0? It would be 3. Now, what is the value of this function when x equals 1? Notice how my line just goes through both holes of this function and doesn't hit any point. Therefore, we say the output is undefined. Now, a good way to interpret this graph is to just think of it as 3 different graphs put together. For values of x less than 0, our graph will follow the function x plus 3. For values of x greater than or equal to 0 and less than 1, it follows the function minus x squared plus 3. And for values of x greater than 1, the graph follows the function y equals 1. If I combine these notations into one, I get my common notation for a piecewise function. Notice how some of my inequalities include an equal sign, while others do not. This is dependent on whether or not there exists a hole in our graph and what the output of our function is. Since the function is defined at x equals 0, we have an equal sign in the inequality. But since x equals 1 is undefined, there's no equal sign in either of these. Here's another example of a piecewise function. What is the output when x equals -6? 0. What is the output when x is -3? Now notice how my line passes through both holes and doesn't hit any point. Therefore, when x is -3, our function is undefined. What is the value when x is equal to 0? Well, one of the pieces has a hole in it, while the other is solid. We will go with the value of the solid circle, which is 0. If both circles were solid, then our function would read, if x is equal to 0, then y is equal to 0 and y is equal to 1. This would fail the vertical line test, and we would therefore conclude that y is not a function of x. So this should never be the case. Again, for a piecewise function, you should look to break them apart into smaller functions. For values of x less than -3, our graph follows the function y equals 0. For values of x between 0 and -3, our graph follows the function minus x plus 1. And for values of x greater than or equal to 0, our graph follows the function x squared. If I combine all these together, I get the common notation for a piecewise function. Notice how these 3 inequalities do not have an equal sign, since they all have holes. While this one does have an equal sign, since it contains a solid circle. Okay, so now what we're going to do is look to graph a piecewise function. Let's start with an easy one. By looking at this function, I know I'm going to have 2 separate parts to my function. One which covers all the x values less than or equal to 1, and another which covers all the x values greater than 1. Let's start by finding the outputs of the first equation. For the second equation, x equals 1 is not included in our domain. However, I will find its output anyway to get a sense of where my graph is headed. See, if I didn't find the output of x equals 1 for my second equation, and started with maybe x equals 2 instead, I would be forgetting to graph all the outputs for values between 1 and 2. Let's look at another one. By looking at the function, I can tell that I have 3 different sections. One for x values less than or equal to -1, another for x values between -1 and 2, and including 2, and a third for x values greater than 2. Let's find the outputs of each section using their given domains. Now let's plot these points and connect the dots. Notice the solid circles versus the open circles. Remember, they are based on which x values are included in the domain, or in other words, whether or not our inequality has an equal sign in it. Also remember why we chose to input numbers not in our domain into our function. It's to see where our function is headed, so we don't accidentally omit certain outputs. Let's do one last example. This example seems a little bit tricky, but if I expand it into 3 sentences, you can see that it is the same as the previous examples.